when I've done this in the past, this class ranges anywhere from 5 to 20 people. And so I found like teams of 5 work pretty well for working on the project. I'll go more in depth to this, but this is like all hands-on. This is all project-based. There's no papers, just some discussion stuff to do, but it'll all be hands-on. And we're going to kind of go. The good part about a team is that I found most teams of 5, you have different people who are interested in different aspects of the final project, and they kind of find the place they like to work in, yet while still learning from each other. Okay, so let me just go ahead and present. Okay, so the agenda for tonight, make sure I'm in here. We'll talk about the class scope and what do we mean by advanced, right? We'll talk about video links and resources used this lesson. So every class will kind of at the top all the resources we used. We'll talk about what advanced is. What do you think advanced means? We'll talk about what software we're going to use. And we'll do a lot of installation tonight to get that all kind of out of the way. And then we'll talk about what we're going to cover. If there's anything you want to cover that we're not covering, we can look into that. And I'll tell you some things that we're not covering just because I think they're too much of a distraction and they're maybe kind of fading in a technology stack, so probably not worth all of our time. The other thing is I'm always updating. I have a master PowerPoint, so I'll be continuing to update that. So if you want to catch it, you may have to keep downloading the same full PowerPoint every time to get all the updates. Okay, so what do we mean by advanced? I found that most of the time when we're talking about advanced, we're talking about how do the pros do it, right? So you have to meet some need, right? You've got a customer or you're running your own business and you want to say, hey, I've got a need. I've got to create a site that's going to perform all these functions. There's a lot of options. There's a lot of architecture choices, right? And then knowing that terminology too is pretty important. Either you guys interested in doing web development, or is this just part of the course? You're just trying to understand some of the aspects of it.
Understand some of the aspects.
Okay. So then the goal isn't necessarily to enhance your resume with a lot of stuff, but I can kind of tell you, what are some of the skills that if you touch on all these pieces, and then in your resume, you could pick up a pretty decent job doing development. If you're not interested in that, which is expected, if you're in a hiring position, or you hire someone who's doing the stuff, and you look at their resumes, you kind of know what some of these things are. So that's one of the takeaways from this as well. We're going to cover more than just, because again, this is a master's degree class, we're going to cover more than just tech. You're not going to sit there and try to learn how to code a web page. It's going to be how do teams interact, how do you make high-functioning web development teams. I always kind of take the point of view that you're either your own boss or you're up in a management structure, and you might be overseeing a team that's doing stuff. So you need to not necessarily know how to do it, but you have to be familiar with it and kind of know what they're doing and make sure they're going in the right direction, that sort of thing. So a lot of that will be, what are some of the planning tools that people use in a team? Because as you can imagine, when you're building these bigger sites, there's a lot of moving parts, right? So how do they communicate? How do they work on the project? How do they get it to fruition? We have one pretty straightforward site that we're working on now, and it's taken 5 of us 2 years, of lots of hard work, right? So there's a lot there. This isn't like writing your own little WordPress site. There's an awful lot to that. We'll talk about integrated design environments, how they use those. We'll talk a little bit about the languages that are used out there and advantages and disadvantages. Third-party libraries and packages. And that can be a pretty cool mind blow. It turns out there's a huge ecosystem of things out there that can do stuff that you don't have to do yourself, right? That you can just kind of install and have it do the work for it, do a lot of the underlying work. I guess the best way to kind of describe it's more like Legos. So you don't have to write all this code. You just need to get all these Legos and put them together to do some pretty big things. We'll talk about how they communicate with each other while developing remotely. So that will come into play here, right? Because we'll be doing some work obviously remotely with the rest of the team members here. So we'll talk about what tools you can use to make that happen. Then we'll do a little bit of the back end stuff, like how do you serve pages up from the web server, and how do you serve data. So that's basically my take on how to look at what advanced development is. Normally I would go around now and do introductions, but obviously we all know each other. What I don't necessarily know is of the terms you see up here on the screen, especially things like like Bootstrap, CSS Grid, Flexbox, Responsive. Just take a minute and go through that list and kind of tell me, is there, of that list, do you recognize less than 10% of it? More than 50% of it? Kind of what do you think of all those terms? I'm just trying to figure out, where everyone is.
I guess less than 10.
Less than 10%?
Yeah.
Okay.
Yeah, I heard that this HTML, JavaScript.
It's better to mention like the one y'all never heard.
Okay, so which are some that you've never heard?
So from the first line I don't know, it's SVG.
Okay.
Second line, WebSAM.
Okay.
Third one, I've never heard Flexbox.
Okay.
Okay. Yeah, IIS. No, Tomcat. No, I know Tomcat. IIS. That
Yep.
one. And the D3 JavaScript.
Uh-huh.
That's I've never heard. And the Confluence. Yeah, I have never heard SPA. And Polyfill. I hear Babel.
Okay.
That's what I've never heard. And Markdown.
So hopefully, if I show you this slide at the end of the class, you'll say, oh, I know all that stuff. And these are things that you're likely to see on a resume from people that might be applying to, work on a team that you manage, that sort of thing.
All of us is about programming, different type of programming, or just like this JavaScript or.
You won't have to do much coding in here. You're totally welcome to do it, but I know that coding, is that what you're asking? Like, do you have to learn how to code, or?
Yeah.
No.
I think this one is related to about programming or different things.
Oh, these are remember,
Terms,
these terms are advanced web development.
Oh.
Okay, so they're not languages. Matter of fact, what I'll do just briefly to kind of go real quick over what some of these things are, just so you get kind of an idea. So you know what HTML is. CSS3 or cascading style sheets. I think you're familiar with, but it's just a way of in the HTML page separating content from style, so that you can rearrange. You can change the style of a page without changing its content. We'll go over a little bit with that. And CSS3 is a lot more than just, is it red? Is it got a bounding box? You can do animations. You can say fade in from the left at this speed and flip upside down. Right? You can do some really neat stuff with that. And I'll show you a cool site CodePen where you can actually go and find cool animations that people have done and say, oh, I like that, and you can copy and paste it right into your page, right, and play with it. So there's that. Lesson Stats we're not going to cover, but just so you know, you might run into those terms, and they're for big production sites where, geez, I need to change 1,500 style elements for this entire site. They can actually, it's a lightweight language where you can kind of program a little bit of code to change a lot of parameters, like, change all the color schemes for these things to this, and it just, it's not going to benefit you for anything we're going to do, but I just want you to understand, if you hear Lesson SAS, all it is it's just a little language that you compile to CSS3. It looks like CSS3. Matter of fact, you can write just plain CSS3 in lesser Sass, and it won't make any changes. But if you need to automate certain things, you can. SVG, you see it all the time. It stands for Scalable Vector Graphics. And where that makes a big difference is that I'm sure you've seen websites or graphics, when you zoom in and they get really pixely. They don't look nice and smooth. We'll show a demo of this. SVGs make it very clean and sharp lines because it's actually a vector. It's drawing a line no matter what resolution you make of the screen. The reason that's become really popular is that it's very lightweight. So for example, there's all these kind of standard logos, like the Twitter logo. You can write the Twitter logo in 100 bytes worth of vector graphics. Here's just my curves and lines, and then fill it with blue. That can scale to a big printed page with very high resolution. It'll work on a small mobile device. It'll look good in both. So it's a way of maintaining a very good-looking appearance regardless of resolution, and while still maintaining small size. There's a lot more to it than that, but just so you understand, SVG is Scalable Vector Graphics. JavaScript, TypeScript, and WebAssembly. I think it's fair to say that almost all the web pages today, in the end, when you download a web page, every web page has JavaScript in it.
Right.
Even if you're using non-JavaScript technology, there's this new thing called WebAssembly, and it's going to get bigger and bigger. And basically, what it is it's instead of you downloading JavaScript to your page, and JavaScript's just text, right? So what ends up happening is when you download your page and you download the JavaScript, you have to have a JavaScript compiler or interpreter, and it looks at the code as text and decides what to do with it. And that's got two problems. One is it's slow, right? Because it has to sit there and walk all the way through all this code to figure out what to do. That slows it down. But also the big problem is if you have intellectual property in the JavaScript code you've written, you're giving it away for free every time someone looks at your page. So if you're, it can be a bit of a bummer, if a company's paying all these developers to create code that they're then letting everyone else look at and copy and whatever. WebAssembly solves both of those. You actually are sending code that's mostly compiled, binaries, and it runs really fast for that reason, and it protects the code pretty well. And the reason I said that all pages use JavaScript, because even to load the WebAssemblies, you have to use JavaScript. So that's why almost every page has JavaScript. I would say right now, and this is a total guess, but I would say, and we could look it up, but if you looked at the entire set of all web pages served throughout the world that have, that are active, have some sort of code in them, they're probably 98%, 99% JavaScript and 1 or 2% WebAssembly. But I wouldn't be surprised to see that more like 70-30 in a couple of years. And part of the reason is there are some web pages, and you could Google this, there's some WebAssembly pages that are full-blown games. And the only way to make those, like 3D rendering, walk-through games work in the browser is to actually download, highly optimized like C++ code and have it run in the browser. So that's one of the ways they're doing that. TypeScript is really big. TypeScript is a language. It's called a transpiled language. So as it turns out, and we'll talk a little bit about JavaScript, and you'll see that it's really flexible. You can do lots of stuff with JavaScript, but because it's flexible, it's a problem. It's very easy to make mistakes that you don't catch until runtime. So TypeScript puts a bit more guardrails on your development. It makes sure that when you are writing it, it can catch a lot of errors and enforce some rules. But when you're done, you compile compile the TypeScript and it converts it to JavaScript. And then the JavaScript is what goes to the, the customer. So the nice part is that the JavaScript that goes to the customer was based on this already checked TypeScript, so it ends up being much more reliable. It also ends up being easier to write. So I might write this much TypeScript and it creates this much JavaScript. That's taking over. It's pretty much, it's kind of interesting. You've seen technologies over the years, right? Flip phones or iPhones, what took over, right? iPhones, everything went to a iPhone form factor. Everything's going to TypeScript. So you won't see it in the download, but if you're a developer team, they'll be working with TypeScript. This next one, Bootstrap, CSS Grid, Flexbox, and Responsive, it's all the same goal. The goal of all of those is called responsive UI, and you use it all the time. All it means is that if you look at the website in your phone,
Right.
you flip it, and it looks good. It's different, but it looks good. That's called responsive design. And of course, the hardest one is when you rotate it, right? Does it looks good vertically? Does it look good when I flip my phone on the side? It turns out that that's not that easy. And so what they're trying to do is they're trying to make it so that you don't have to, it wasn't that long ago, you would have to serve up a different page. If you turned it horizontally, it would say, oh, CNN, Jihan just turned his phone sideways. Give me the sideways phone website. And so they have a whole different site that's kind of optimized for that. Well, you can imagine how hard that is to maintain kind of a couple of different sites. So years ago, they came up with some patterns that people use to make it so that one site will adapt, be responsive to whatever the UI is. And so we'll go over those terms, Bootstrap, CSS, Grid, Flexbox, and how those work. The next line, the Node, Express, NPM, Apache, Tomcat, IIS, Web API, those are just ways of getting the web page off the back-end server and off toward your client. What we'll find, I'm not going to go into detail right now, we're going to go into that deeper in a later class, but have you heard of Apache? That's relatively common. That was like the big server. The other big one was IIS, the Internet Information Server from Microsoft. They are not, well, Apache is still serving up the majority of content, but it's being rapidly superseded by Nginx, which a lot of people have never heard of, or Node.js. There are a bunch of these other servers that turn out to be easy to use, free, lightweight, can deploy them on lots of servers very easily. So they're kind of taking over. I think that the number one winner right now is Nginx. We're not going to go over Nginx at all. We're going to use Node.js just because it's easier. We can do everything in this class, as far as the projects go, with a smattering of JavaScript. So Node.js is the server. That's all in JavaScript. Mostly what we'll be doing, since again the expectation is not that you're learning how to code here, but you're learning how to take some existing JavaScript or TypeScript and know how to read it somewhat and modify it a little bit to do some things. If you're really interested, like if some of the folks that are remoting are really into learning that, we can do that too, but I know that's not what everyone's goal is and where everyone's warm and fuzzy area is. So there are other areas that don't require any coding, and we'll be getting into those. D3.js and Chart.js. Remember some of the Legos you can use to make cool things? Those are graphing Legos. So you can take a quick little CSV data file and using one of those make really fantastic graphs and charts. Git, Bitbucket, GitHub, Agile, Jira, Confluence. Those are management tools. They're ways of storing your code, ways of working with team with code. No coding there at all, but you will want to learn about Git. Git is kind of the de facto global standard for source control these days. It was written by the same guy that wrote Linux. Torvalds wrote Git, and you know what the Git stands for?
Yeah, weird. It's like weird, right?
It's weird.
I know.
It's I thought it was an acronym, like globally something technology. No,
Oh, it's not right.
no, it's not an acronym at all. It's let's make sure this isn't one of the guys calling in. It's looks like we're good. It's just a if you heard the British term, you know, you stupid git. So it's kind of self-deprecating. So git means like, you know, a fool,
Oh.
right? So it's just self-deprecating. You know, he's like, I'm a silly git. So, and the crazy part is, I forget what the time it was, but it was short. Like he wrote it in a couple months.
What about the GitHub?
And that's what GitHub is from, right?
Exactly.
Right.
That's
So
what I heard.
yeah, so GitHub is a website front end and management tool that's built on Git repositories. So we're going to spend quite a bit of time with Git because I think it's a useful tool for you to know not only how it works, and with GitHub, it's project management. So you see the back-end stuff. You see things like bug request tracking, activity rates, you know, who's doing what. We'll talk quite a bit about that. It's a good thing to know. And again, it's not related to programming at all. You can do all your documentation.
Exactly, that's what I use for. Like,
Yeah.
documentation and stuff. You can copy and paste a lot of codes. I mean, you can get free codes out there.
Do you use Markdown? Are you familiar with Markdown at all?
No, that's what I don't know.
Okay, so that'll be good. That's the last one there. So Markdown. So John, did you ever do like old wiki sites? You ever put anything on a wiki site or dealt with the old wiki style stuff? You know, where you don't have you know what a wiki is, obviously, like Wikipedia. When you create content in Wikipedia, if you want to make something bold or you want to make bulleted lists, you don't do it like you do with Word, right? You don't select some text and hit, you know, make this a bulleted list. What you're really doing is you're storing text in Markdown, which might mean if I have a plus space and then some text, next line is plus space some text, it'll automatically make that to a bulleted list, right? So the advantage of this sort of stuff is you can fly very quickly. You can create, you know, just, hey, I'm writing my paragraph. I need a new heading. I do pound space, that's heading 1. Pound space is heading 2. Pound space, heading 3, right? You can do just normal text, no special, you know, XML, HTML flags. You just normal text. You can create enough Markdown data so that a Markdown compiler will make a web page for you. It'll make a PDF file for you. And there's entire websites that are completely based on that, where you write your blog or your instructions in Markdown. You push your Markdown up to GitHub, and then the GitHub web page is rendered to HTML for your clients or readers. You can do that today. I can even show you. You can do it today for free on GitHub as a global website for, you know, your documentation. It's pretty cool. That's what I'm playing with right now. It's really cool. Completely free. You get to do one for free from GitHub. I'm coming back up from the bottom. That Polyfill, Babel, Webpack modules, ES5, ES6, all of that has to do with solving one really big pain in the neck problem with JavaScript. And that's that JavaScript has evolved rapidly. You know, they called what they called JavaScript 3 years ago doesn't look anything like JavaScript today. And if you go back 6 years ago, it doesn't look anything like what it looked like 3 years ago. They've been moving the standards so fast that, yeah, that you have a problem, which is if you're using an older browser, it can't read the newer JavaScript, right? So they've done all this, you know, Band-Aids, duct tape, baling wire approach so that if you write code, it'll work in these different browsers. One of the common ones, like polyfills, would be I'm a server and I say, hey, Amanu's just downloaded my web page. Ah, crap, he's using IE8. So what I do is I have this polyfill in there, and this code detects that you're using IE8 and says, oh, because you're using IE8, I'll download this additional code, and it will fill in the gap for the missing capability of your browser. Babel is a different approach. Babel is you write in the latest version of JavaScript, and then you say, oh, I'm targeting, Safari 2. I'm hitting Google Chrome 40. We're at 80 something right now, right? So you can tell whatever you're shooting for, and it will compile this nice new, easy, clean JavaScript to kind of maybe older, more bloated JavaScript that'll work on the older machines. So as you can imagine, that's just a way to really save you time, because you don't want to have to keep rewriting. You don't want to have to ship really old code that's very hard to maintain but works on everything. You'd rather use the new features and compile with the new features, and then for those fewer people that are working on really old browsers, let it, do some stuff automatically for them. Even though their experience might be a little less, it'll still work. Webpack and modules, that has to do with the fact that, and we'll look at some commercial pages when they download. You might be bringing in 40 or 50 dependent libraries. So as you can imagine, this thing's interpreting the code as it's going through. Well, I'm pulling down one library that depends on another library. The browser may be pulling them in. The one that I need first might come after the one I need second. So the code would break, it wouldn't work. So there's all this technology to make sure that it waits, it asks for all this code to come in, often from different places, different locations. I don't know if you knew that, right? Not the JavaScript that's in your web page may not all come from the server that you're talking to. In fact, most times it doesn't. You'll be getting code from a bunch of different places. So it'll take longer depending where you're coming from. Some of those connections will be slower. So how do you orchestrate it so that you don't wait for every freaking thing to come back before you start running through the code? If you do that, you might wait 5 seconds before your page is even slightly starting to react. It can sit there and say, well, as soon as I get this one, I can then go down to this part of the page, and do this part of the code. And if I try to do this piece of the code, I have to wait for this one. And so it's all about optimizing, the experience for the user by organizing that stuff. ES5 and ES6, those are just versions of JavaScript. ES5 is like 5 years old. ES6 is 3 or 4 years old. Even though they're only like a year or two apart, they're very different. Totally, hugely different features in them. A lot of pages are still on ES5. If we do anything, we're gonna be doing it in ES6. I don't know why I put VS Code and jQuery in the same line. You might have heard of jQuery.
Yeah.
All that is it's a very widely used JavaScript library, and it wraps the DOM. You know what the DOM is? Does that acronym ring a bell? It's a document object model. It's how you access, describe, modify elements of a web page. So a web page has like a head and a body. So with the DOM, you could say, oh, I want to get some information from the head. For example, I may want the title. I might want the metadata. I might want to find in the body the every heading one, and modify every heading one. You do that. That's what the DOM is. It's this. It's the web page accessible as a programming API. So jQuery makes a lot of that simpler. So I'll give you an example. Let's say all you wanted to do was to hide a button. So with normal DOM, you would say document, get the element at this ID, find its attribute, or add this attribute called display, and set the value equal to none. So it's this really long line to hide the button. jQuery might just have something like $, parentheses, the button ID, like pound some ID dot hide. So it just makes it a little easier. It automates some of the, simplifies some of the syntax, and that's why it's so popular. The last one we'll cover is that SPA, Vue React Angular. SPA is single page application. You've probably used them a lot. So whenever you go to a website where, you know, the old way of doing things, you always go to a different page to do something different. But like if you're at your bank site, right? Maybe you're at your bank and you're looking at your accounts and you're clicking on an account and it's expanding and you never really leave that page. That's a single page application. As you can imagine, for you to stay on that page, what's really happening is that DOM, the document object model, is constantly being changed. And that's that's very hard to coordinate well. It's not obvious. I'll try to do a demo later in the class so you kind of see why it's hard. But code like React, Angular, and Vue, they're huge frameworks that people are very opinionated on. You'll have people like only use Angular or only use React, and they're frameworks that make doing a single page application easier. I think Facebook is React based. I'm trying to think what big site is Angular based, but you know, it's kind of funny. I mean, you get some people that are highly opinionated which one. There's really 3 biggies right now. If you were to teach someone how to do React or Angular, that would probably be a solid 18-week class to do it properly. So that's why we're not even going to try. It's just too much, and you don't need it. So if you're doing your own simple app, there's no need to learn any of that stuff. All right. So what I just talked about for the last 15 minutes, that's basically of what we're going to be doing. Everything.
In this
Yep.
modern time.
So and I don't want to. I'm trying to find the right balance where we're not getting too deep technically, you know, where we're losing people that don't want to do this low-level stuff, unless people do. So if some people want to do it, they can do that. Not everyone has to. And then there's these other aspects that are much more project management, team building, team direction, architecture related, that are very applicable to anyone who's looking to manage a team, run a team, run a department. You'll need to know those things. And so what I'm hoping is, if you guys all work on a single project, you know, some of the guys that want to really go down and do some coding might focus on that. Some that might want to focus on documentation and planning would do that. You can kind of all specialize. But I'm totally amenable to however you want to do that. But I do think this is a course that's not well suited to writing papers. I think it's well suited to actually doing things, right? All right. How are we doing? What time is it? I want to make sure I'm not wearing you guys out. Coming up in 10. We'll probably take a break in 10 minutes. Okay. So what's currently hard? Do you know what the concept of a single-threaded or versus multi-threaded applications? Do you understand that? Because I can go into it a bit. Have you heard that term, multi-threaded,
Yeah,
single-threaded?
I heard.
Okay. So what that means is that the computer, you know, is working on an instruction, right? It can work on any set of instructions, any one core. So your laptops probably are 2 to 4 cores each, somewhere in that neighborhood. You might have more, but what that means is that at any one time, 4 different sets of instructions can be simultaneously acted upon. Now what happens under the covers, and this might blow your mind a bit, if you were to look on your computer, you may find that at any point in time you have 50,000 threads. So how does that work, right? You can only do 4 at a time. How can you have 50,000 threads in your machine? Well, what ends up happening is, in memory, they're constantly exercising a few lines in one thread. Then they're doing what they call context switch. They kind of leave that in memory. They tell the CPU, okay, leave a bookmark here. Now do this one, and it keeps going. And so it might be switching. I think in Microsoft Windows, it's every 12 microseconds it can switch a thread. Right? That's how fast it's switching between them. So it gives you this illusion that all these things are happening, right? It's downloading your email, it's updating your clock, it's listening for traffic, it's scanning for viruses, right? All that stuff's happening on 50,000 threads, of which only 4 are ever really running at a time. So, why do you care? Well, you care because it turns out with all those threads running, a web browser window is typically only ever given one thread. Now, there's caveats there, but just for the point that I'm trying to make, let's just assume that you just got one thread in the window. So what that means is that if that thread is waiting for something, the operating system will come back to it. It'll go and do these other threads, but it's not going to do anything else until that thread can keep going. So if there's anything blocking that thread, nothing's going to happen in your UI. And I'll give you a classic case where they get blocked. You might have heard the term AJAX or XHR. It's the technology by which a web page, after it's rendered, goes out to a site and gets some information and updates your screen. Classic case, you're looking at Yahoo Finance or something, and you're watching stock tickers. So while you're watching it, it's going out to Yahoo and says, give me the next price, give me the next price, give me the next price. Right?
Is that like Sumo with the API?
It's a REST API sort of thing. Yeah, it's probably a REST API, exactly. And it's going out and it's getting a little chunk of data to come back. If your thread says, oh, go get me my next data, and I'll wait until you come back and respond. Maybe it goes to Yahoo, comes right back in 10 milliseconds, gets the data, comes back. So what you would notice in your page, not much, right? You would have this imperceptible delay in the update. What if it goes out and says, hey, get me the price on Boeing, and the server is down, it says doesn't respond. So you what do? You have a few options. You can tell it, well, wait up to a certain amount of time, and then bail. Typically it's called a timeout. So what would happen is, while you're waiting for that reply to come back, your entire web page would be non-reactive, which means if you clicked on a button, it wouldn't work. So think about the difficulty there. You're going, well, I've got these threads that need to go out and talk to all these different servers. It could be that every now and then they're a little slow. Maybe it takes a second or two. So I don't want it to fail all the time. I'll pick some number that's reasonable, like, yeah, it'll be done in 5 seconds. So you say, I'll put a request on this loop. Every 10 seconds, go check my stocks. Every 10 seconds, go check my account balances. Every 10 seconds, go check this or that. All these things are coming in that single page application, right? So every time they're going out there, there's a gamble that they're making, which is, I have to have a timeout in case it doesn't come back. If you're doing that all with one thread, any one of those gamble bets that doesn't pay off and you wait till 5 seconds means the entire page is frozen for 5 seconds. So obviously you don't see that, so there are ways to not deal with that to get around it. But that's one of the big problems with web pages, that they only have one thread to work with. So it turns out you have to do some cute tricks such that your page always looks reactive even though there's only one thread. And we're going to go into it later, but I just want to let you know that's a big difficulty. And one of the things that they use to solve that problem is called promises. It's a coding technology. It was in ES6. Remember I said the difference between ES6 and ES5, 2 different versions? ES6 has promises, ES5 does not.
It's cloud-based.
It's just a coding feature, right? It's a language feature. You can, if you're writing an ES5, you can actually type something called promise, and it knows how to read it. It knows what to do with that code when you write promise. If you write that in ES5, it goes, I don't know what promises are. That's the case where you use a polyfill. So you use this other code that says, hey, if your browser can't do ES6, I'll read it. I'll write it as ES5 with polyfill that defines what a promise is. So anyway, there's an awful lot of work in making these react smoothly and responsively and not hang up when things are going on. Another thing that might hang up code would be if your code is doing some heavy lifting, like doing some statistics or calculations on that thread. That could also make things unresponsive. So how do you solve that? So there are issues that they're using to solve those, and we'll go into those later. But I just want to let you know that's a difficulty. We already talked about the other one, right, which is loading all these different files. Graphics coming from different places, fonts coming from different places, jQuery coming from one place, your graph charting files coming from another place. They're all coming in at different times. You've got that one thread. You got to make sure they all get in at the right sequence. You've got to make sure that you're doing everything you can to make your page more responsive. Because you probably know already, what's the time that they tell you at which, if your page hasn't loaded, your customers typically have bailed? Do you know what that number is? You just did your website to sell your new product, and your website doesn't come up for how many seconds? What's that time by which your customers already left the page? It used to be 5 seconds. You know what that number is now? 2 seconds. So if your page takes 2 seconds to load, I forget the exact statistic, but I read it not too long ago. It was something like 30% of your customers are going to leave your page before it loads if it hasn't loaded within 2 seconds. Well, there's latency, right? But latency, from halfway around the world is typically measured in tenths of a second. 0.1, 0.2. From here to India.
Milliseconds.
Yeah, milliseconds, right? From here to India, it's like 300 milliseconds, so 0.3 seconds. But you're waiting for different traffic, so maybe the server that's responding to your request is slow, or maybe your processing of the code, compiling the code is slow. So all these things add up. And so if it adds up to where your page just looks blank, they're like going, oh, I just went to the site. 1 potato, 2 potato, oh yeah, forget it. Right? Because you're going down through your list of Google results, right? Click. Yeah, no. Click. Yeah, no. You've done that before, where you're clicking on some of your search responses, and if the page kind of opens up and doesn't load for a few seconds, like, oh, I got 50 other things to look through. I'm going to keep going. So that whole notion of latency is important. We already talked about the managing code complexity, and we already talked about JavaScript has changed significantly. So in this class, we're only going to use the latest technology. So by picking ES6 as the language we're going to use, we don't have to deal with any of these issues. We're not going to worry about old versions of browsers. We're not going to worry about polyfills and Babel and all that kind of stuff. And don't worry if I don't want to scare anyone off from programming. We'll do enough that anyone can get through it. And if you want to go down in the weeds and you're a pretty good coder, you can do that as well. All right, let me see if we're getting close to break time here. This isn't advancing. Oh, so these are the resources. I just put this in the page so you can kind of see. Whoops, sorry. So you kind of see what's available for use. There's some videos here. We'll watch some videos when we come back from break. These are the videos that we're going to watch tonight. We'll finish on this slide and we'll take a break. So we've already kind of talked about what's advanced, right? What's industry relying on to make them productive? and these are the things that you'll want on your resume if you're doing them, or you'll want to understand when you see it in other people's resumes. As a professional, a web dev is spending 40 hours a week doing this, right? So they're in the work environment. They're constantly getting tips and ideas from other coworkers. So that's how they're discovering technologies, right? So you can imagine you're getting your PhD in this effectively, right? For any job you do, if you're in it 24 hours, 40 hours a week, you're becoming pretty good at it after a few years. So what ends up happening is, people are on blog sites, on Reddit, have talked to friends, have visited sites and go, hey, why is this site so cool? How did they do that? And the cool part is you can figure it out. Almost any website, you can go behind the scenes and use the diagnostic tools to figure out how they're doing it. So they go, oh, they're using this cool library. Maybe we should use it for ours. So this kind of pollinates through, and this is how these developers will learn about all these different technologies. So what that means is, if you're using something to display your corporate data, here's our sales are doing, maybe to your internal marketing team, and it's pretty clunky, but it was the best thing. 5 years ago, you paid maybe good money for a library to do something. If all of a sudden people are finding there's something better on the web for less, that's just going to get replaced, and you're going to see it ripple through. So there's a pretty rapid rate of change on those. So at this point, why don't we go? I'll pause as we take a 10-minute break. We're going to come back and watch this kind of video. It's a long video. We're only going to watch like 10 minutes of it. You can watch the rest of it if you want, but the first 10 minutes talk about kind of where things are going. And then after that, we'll start doing some installs.